Dear student, I am Dr. Sharad, working as an Assistant Professor, Department of Chemistry, Chem College, Nasik. I welcome all of you to second year B.Sc. Analytical Chemistry classroom. Paper code is CH-301 and section is second. Chapter name is Errors in Quantitative Analysis. In today's lecture, we can see the errors, accuracy and precision. Dear students, in last lecture, we can see the revision of analytical chemistry, in which analytical chemistry. So what is meant by the analytical chemistry? That is nothing but the identification, separation and quantification of compounds present in the sample. Then chemical analysis and types of chemical analysis, qualitative analysis and their types, in which organic qualitative analysis and inorganic qualitative analysis. Then quantitative analysis and their types, in which weight or classical methods of analysis and instrumental methods of analysis. Then we can see the stages involved in chemical analysis, that are 8 stages. Then sampling, in which solid, liquid and gaseous sampling. Types of chemical analysis, in which proximate analysis, partial analysis, trace analysis and complete analysis. Then depending on size, major constituents, minor constituents, trace and ultra trace, meso, macro, like this up to the nano trace. Then factors affecting on choice of methods, in which available facilities, infrastructure, laboratories, equipments, like this. In this lecture, we can see the introduction to errors in quantitative analysis, then quantitative analysis, accuracy and precision. If you can see that errors in quantitative analysis, that means the quantitative analysis is the important parts in this chapter. So quantitative analysis, which is related to the how much amount is present. That means here the compound is known. Compound is known. The major difference between qualitative and quantitative, that's in the qualitative analysis we can find out, or we can say identify the compound, but in the quantitative analysis we can find out the amount of compound present in that sample. So here quantitative analysis is most important, because errors which we can find out which is related to the amounts, or we can say the quantitative analysis. In the quantitative analysis, the two important terms are involved, in which the accuracy and precision, which is related to the results. The accuracy, which is related to the closeness of the corrected value, and precision, which is nothing but the reproducibility. These are the two terms which are very important in the analysis. We can see one by one. Errors. Errors is defined as, in the quantitative analysis, error is a particular value. Error is the particular value that may be known if the true value is given. If the true value is given, that means the standard is known, and when we have to perform the analysis, we can compare our results with that standard, and whatever the difference is coming, that is known as the error. The error means a failure of some kinds of uncertainty, which include mistake. In other words, where mistake is done, we can say that is the error. But it is not happen in the analysis to identify that mistake easily. From this error, there are two major types. One is determinant, or we can say the systematic error, and another one is the indeterminate, or we can say accidental, or another name is that the random error. If you can look the name that is the determinant, that means you can identify the mistake or error that are the systematic errors. Indeterminate or accidental, that means we cannot identify easily, or it is occurs randomly or accidentally, so which is not in our control. For that purpose, in the indeterminate error, some statistical calculation is given, and in the determinant error, we can minimize that error by identifying where the error is occurs. So, in the determinant error is again further divided into the four major types, in which operational or personal error, instrumental and reagent error, errors of methods, and last one, additives and proportional error. We can see in the next lecture. Then quantitative analysis. The quantitative analysis deals with the how much of one or more constituents present in the sample. That means how much. We can find out the amount. How much of one or more constituents is present in the sample, that is the quantitative analysis. And that quantitative analysis is again divided into the two parts or two types, that is weight or classical methods of analysis, in which we can see in the last lecture, that is gravimetric analysis or volumetric analysis, and in the instrumental methods of analysis, in which electroanalytical techniques, spectroscopic technique, chromatographic technique, separation technique, thermal methods of analysis, kinetics methods of analysis, X-ray methods of analysis, optical methods of analysis, like this. So you can see that the quantitative, that means by using these methods, instruments or classical methods, we can find out the amount, and our aim is errors in quantitative analysis. That means we can find out the mistake where at the time of analysis is done, and that mistake we have to identify, and again it is minimized by using next analysis or improve in the next analysis. In this errors in quantitative analysis or any types of analysis, two terms are most important, that is accuracy and precision. So we can see first what is meant by the accuracy. So accuracy related to the closeness of measurement to the accepted correct value, or it may be defined as the degree of agreement between the measured value and the true value of the measurements. So accuracy. So what is meant by the accuracy? Accuracy is nothing but the closeness of measurement to the accepted correct value. That means some standard value is given, and when we have to perform any experiment, that experimental value is matches with the standard value or near about that, that is the accuracy. If that is matches 100% to the standard value, that means it is 100% accurate, or 100% accuracy occurs. Then it is expressed in terms of absolute error and relative error. By using absolute error and relative error, they can give the more information regarding the accuracy. And any analysis in which that reliability of results, which is depending on the accuracy of data. That means for the accuracy, you can perform the same experiment in number of times, and then you got the corrected value or closeness towards the true value or standard value. That is the accuracy. If you have to perform the experiment several times, then and then you got the 100% accuracy or near about that. This is all related to the accuracy. Then what is meant by the precision? So precision is related to the reproducibility of the measurement. That means reproducibility of the measurement. It may be defined as the degree of agreement between the replicate measurements of the same quantity. Replicate measurements of the same quantity or reproducibility of number of similar measurement under identical condition. So precision related to the reproducibility, and that is expressed in terms of deviation, mean deviation, standard deviation and relative mean deviation or relative standard deviation. In many instruments we can see the percent RSD. So RSD, which is related to the relative standard deviation and which is the statistical terms. So we can see the accuracy, which is related to the closeness of measurement to the accepted correct value, and precision, which is related to the reproducibility. So we can see both, that is accuracy and precision, with the help of this diagram. All of you know this is the targeted circle in which this black spot is seen. These are the 6 round, and in this 6 round the accuracy is here, like this. So here is the low accuracy and low precision. Why? The accuracy, which is related to the closeness towards the corrected value, and our corrected value is in this circle, central. But here is the only one black spot is you can see, and other are around that, and which is scattered. So here is the low accuracy. Second, low precision. Why it is low precision? Because precision, which is related to the reproducibility, but here we cannot see the reproducibility. That's why here we can see that the low precision. If you can see here in the figure B, high accuracy. So what is meant by the high accuracy? Because all these 6 balls are in near to the targeted molecule or within the circle or around the circle. That means the accuracy is high as compared to this A, and precision is low. That means the reproducibility is not that much good as we can see. In this C, we can see the high precision. That means the reproducibility is high but accuracy is low. When all these 6 are in this central, then there is the high accuracy, which is seen in the figure D. Here is the high accuracy and high precision. So accuracy, which is related to the closeness of the measurement towards the corrected value, and precision, which is related to the reproducibility. These are the 2 important terms which is used in the quantitative analysis. So in this lecture we can see the introduction to errors in quantitative analysis, accuracy and precision. So precision is nothing but the reproducibility, and accuracy is nothing but the closeness towards the measurement of corrected value. In next lecture we can see accuracy and precision and their methods of expressing the accuracy and precision. Here methods like absolute error and relative error. In the precision, deviation, mean deviation, standard deviation, relative standard deviation, like this. Okay, thank you.